Now this is a start of a video series on ratios, and the reason why I'm going to do this is because of Euclid Book 5. I have been discussing Euclid Book 5 now for quite some time, and we're about 6 proofs away from being finished with Book 5. Book 6 also deals with ratios, but we're going to take care of that, well, as soon as we can. We're also going to be talking about the Greek letter sigma, which has a direct relation to ratios. And I know you don't believe this right now, but you're going to find out that the Greek letter sigma and ratios kind of go hand in hand. Now, let's talk about a few ratio properties, shall we? First of all, there is a thing called the inverse ratio. What is an inverse ratio? Well, it's when you have two ratios, and if you multiply them together, their product comes out as 1. Let's start with this ratio here. We have a 3 over 2, which is a 3 to 2 ratio. We have a 2 to 3 ratio. Well, if you multiply the 3 to 2 ratio with the 2 to 3 ratio, you'll get 6 over 6. And, of course, 6 divided by 6, of course, is 1. So that's an inverse ratio. Right here is an inverse ratio. You've got your 3 to 2 to 2 to 3, and boom, there you go. Now, what about a duplicate ratio? Well, if you have a ratio, like, say, 3 to 2, you have a 3 to 2 ratio, and you square the 3 and you square the 2, you have a duplicate ratio. Now, if you raise the ratio to a power of 3, you'll have a triplicate ratio. Okay. Now, if you end up square rooting the antecedent and the consequent, which this is the antecedent up here and this is the consequent down here, if you square root both, then you'll have a subduplicate ratio. And that's about as much as I was able to write on this board for this particular video, but I will tell you more terms in just a little bit. Stay tuned.